Okay, so if we're talking work problems here, I need you to get something across. If they tell you Norm maker, it's supposed to be makes. Norm makes 120 yo-yos per hour. Okay? He works on an assembly line and he manufactures yo-yos and he makes 120.
Wait, that's a name?
Yeah, Norm? Short for Norman? Okay. You obviously never watched Cheers. The old famous TV show, comedy.
Or Norman Arthur.
Meanwhile, Norm makes 120 yo-yos per hour. So what's Norm's rate? How fast is he making them?
120
120 per hour.
But how long is it? How do I get this?
How many can he make, like, per minute?
Not per minute. I want him, so how long does it take him to make one?
Okay,
One for 30 seconds.
Yeah, that's actually true if we went to minutes or seconds, but I want to stay in the per hour.
120 over 60.
I want you to go, you're converting again. I just want you to go, so to make one of them,
30 seconds, 0.3.
to make one of them, how much of an hour does it take?
0.3. 1 over 120.
Yeah, wouldn't he make 1 over 120? Takes him 1 out of 120 per, okay? So that's how you turn it into a rate. So if that's Norm's rate, and Norm, so we're going to have Norm's rate, Norm's going to have a time. So if Norm has a rate and a time, if I take you back to his 120 per hour, if Norm works for 2 hours, how many will he make? 2 hours, he's going to make 240. So would you agree that rate times time equals, in this case, the amount of work he gets done? Okay? So that's our formula of the day here. Rate times time equals work. Okay, now, taking that little concept, look at, on your example sheet, we have number 3, Charlene and Robert, who are washing cars for a fundraiser. Alright? And Charlene can wash a car in 15 minutes, Robert can do the same size car in 12 minutes. And the question is, how long would it take them if they worked together on this job? So once again, I love my boxes. Makes you organized. Okay. So what formula do I want? Very good. Rate times time equals the amount of work we get done. Okay, and so we got Charlene here, and what was the other dude's name? Robert. Robert. Okay. What is X? What do they want to know?
They want to know how long it takes to wash one car together.
How long will it take them to wash a car working together?
They want to time.
So they want to know time. So X is going to be the time working together. We know how long it takes them individually, but how much time would it take them if they worked together? Okay. So we need to have it figured out, though, what Charlene's rate is. If Charlene can do the whole thing in 15 minutes, what part of the job is she doing per minute? She does the whole thing in 15 minutes. How much of it is she doing in 1 minute? 1 over 15. Is she doing 1/15 of the job? So her rate is 1/15. Which means Robert's rate is what? 1/12. Very good. Are we getting, there's a pattern here. Okay. Now, how long are they working? What's their time? Very good. X. They're working X amount of time. Okay. So what's the amount of work going to get done that they get done?
150.
Yeah. So you're going to multiply. This is multiply. So you're just going to multiply across. You're going to end up with X over 15 and X over 12. Now, here's the part that's a little weird with these. Okay. That's the fraction of the job each person's going to do. Okay. Together, they're going to get the whole job done.
So add.
You have to add them because they're working together. But the question is, what does it equal? 1. They're each doing a fraction of the job. So if they get the whole job done, the number that represents a whole, is 1. It just has to equal 1. I always have people want to make it equal some other number. Just 1, they get the whole job done. End of story. Okay, is that going to be hard to solve? We could solve this one in August. So anybody know the common denominator for 15 and 12? 60. Yes. Okay. So 15 goes into 60 how many times? 4, so we get 4x. And 12 goes into 60 5 times, so we get 5x. Equals 1? Thank you, equals 60. Number one mistake I see in these problems, we forget to multiply that 1. I always have people who leave it as 1. Multiply it by the number, you got 60. You get 9x equals 60. And if I divide that by 9, and I could reduce it by 3s at least, that'd be 20 over 3. Or in this case, since it was how long they're going to work, how long would that be? Divide it. Actually, I'm going to tell you to turn it to a mixed fraction for once. 6 and 2. So it'd be 6 and 2/3 what? They were working 15 minutes and 12 minutes. So, man, look how fast they could knock cars out of this car wash like zing, zing, zing. They work together. So you shuffle those cars through. So there you go. Next time you're doing a car wash fundraiser, time it. Work together. Figure out how long you're going to do. Okay, great. Okay. That's one example. I wish to do one more of these just to get it across here. So I also want to look at number 4 because it's got a little different twist. We have Jim and Alberto. They have to paint a 6,000 square foot hallway. 6,000 square feet of space they have to paint. Wall space or whatever.
Well, so that's the same floor space.
Yeah, wall space. How much wall space they got to cover? I mean, they painted floor, yeah. Wood, cement.
Yeah, but up here,
You could lots of people paint their basements or even floors, yeah. Or you, yeah. You can paint a floor. All right. So, but meanwhile, I think they're actually painting walls. This is in an office building, so I really doubt they're painting the floors. Okay. But Alberto works twice as fast as Jim. Working together, they get the whole job done in 15 hours. So the question is, how long would it take each of them working alone? This is a different trick. Okay. So, Eric, what's our formula?
The R times the rate equals
Rate times the equals the work done. And what are our two situations? We have Jim and Alberto. Okay, and then the other big question, what's X? What are we supposed to figure out?
X would be Jim.
Says how long would it take each of them if they were working alone? Okay. Are they both working at the same speed?
no, Jim is working 5.
Okay. So we don't want to set it up with two variables. So you need to pick one of them. Are we doing, is X going to be Jim or is X going to be Alberto? We need to set up one.
Alberto.
Jim's X? Okay, so actually, so then what's the question? What is Alberto's speed? If Jim is X, he's twice as fast, so yeah, so 2X is Alberto's speed. actually, I shouldn't say speed, I shouldn't have written speed, Jim's time. Because it said how long would it take them, sorry, Jim's time alone. I shouldn't have said speed, that was bad.
So when it's Alberto.
Okay. Now, if Jim is working twice as fast, would his time be 2x? Because if Jim takes 2 hours, Alberto's going to take 4?
No. Oh, and how?
Oh.
Yeah, so you actually don't want to do that. Okay. This is think about how we got the rate back there on the last one. Why was Charlene one's rate 1/15? Because she took 15 minutes to do it, so her rate was 1/15. Okay, so if Jim takes X amount of time to do the job, what's his rate? He's 1/X. Okay, so that's his rate. And did we know?
Alberto works twice as fast.
Okay, Alberto works twice as fast. So what do we need to double? If his rate is 1/X, Alberto's rate is
1/2x.
Cause are you wanting to double the bottom number or double the top number? I know, it plays with your brain. Yeah. Yeah. Okay, so then, if he does twice as much, wouldn't he do a bigger fraction of the job? He's faster, so he should have a bigger, the top number on the fraction makes it a bigger fraction. He should do a bigger fraction of the job. Okay, this is what's weird. What time do I use then? I can't use X's for time because I got X's here. Why 15?
Because that's when they got it done.
They're gonna, when they work together, we know they work 15 hours. So this time we knew their working time was 15. Okay, so therefore what's Jim's total amount of work he gets done? Multiply, you're multiplying, one, just multiply across, it'll be 15/X, and this is gonna be 30/X. Now, when we go to write the equation, they're working together, so how much of the job do they get done? You're adding it, and they get the whole job done again. That would get the whole job done, because each one of them is doing a fraction of the job. Okay, can we solve this?
Yeah.
Doesn't look too bad.
45.
What would I, ooh, I could add, she's right. I could actually, those are like terms, I could actually add them. How cool is that? So, okay, now, incredibly difficult. How would I solve for X? You would multiply by X, and golly gee, X would equal.
Wow.
So Jim's time alone is 45 hours. But you gotta realize, this 6,000 square feet is a lot of area to paint.
Wait, so,
That would be, it would take you,
Jim 45 hours.
yeah. Yeah, if he works by himself. If he works by himself, it would take him 45 hours. Together they did it in 15. Yeah. Yeah. So, that's good. Okay, so I'll admit these can play with your brain a little. They're actually really easy to solve. They aren't complicated setups, but they'll. Oh, whoops, did it ask for Alberto? Oh, it did. Whoops, sorry about that. Okay. Okay. Because if he's doing it twice as fast, so it won't Alberto take less time? Yeah. So this would be Jim. Alberto's more experienced. Yeah. He'd be half of that. Maybe Jim's just new. Maybe he's a brand new painter. Alberto's got skills. Jim's a trainee. All right.